Hello everyone. Today we're going to be talking about impulse, which is the counter and cause of changes in momentum. So we are specifically interested in changes in momentum because those are the things that we interact with in our day-to-day where we're feeling force on our bodies or on a body. So how can you reduce an object's momentum to zero? This is a thought to think about. How do we reduce it? How can we increase the momentum? What if you want to change the direction of momentum? The answer to all of these is in the first law of motion. To alter the object in motion, it must be acted on by an unbalanced force. So unbalanced force, remember that forces come in pairs, but if you add up all the forces acting on a body, they might not be balanced. And this is, in fact, often the case, especially for anything that's accelerating. This is the act of unbalanced forces. There are two things you can do to alter the momentum. You can apply a force, the larger the better, and you can increase the amount of time the force has been applied. So think about it like if you want to slow down your car, you can do that in two different ways. You can stomp hard on the brakes, right? Apply a force immediately for a long time and apply a hard, strong force, right? Pushing down really hard on your brakes and holding it there. If there's somebody in front of you and you need to stop, you're going to put down your foot on the brake, push hard, hold it there, and the car is going to stop quite suddenly and quite quickly. The other option is you could feather the brake, right? You could apply a little tiny bit of force, just a little bit of the brake, and on and off, and that might help you, slow down gently. You don't, not always do we need to decelerate so quickly. Similarly, we can apply the full force of the engine by stomping down on the gas pedal of your car, and your car will rocket forward as long as you're holding down on that pedal. If you want to gently increase your speed, you could apply a small amount of force for a long period of time and gently accelerate. Or if you stomped on your gas pedal, but repeatedly, but lifted your foot off right away, then your car would kind of jerk forward and start to slowly increase in speed, but in a very in small spurts. And over the time, it would probably be accelerating slowly. So this is an impulse that's being applied. An impulse is a force applied over an interval of time, and they are calculated in the following equation. Impulse equals force times the time interval. So an impulse is equal to force times the time, and it is represented by a symbol I and is measured in Newton seconds. So this is a Newton times a second. Once again, both momentum and impulse have kind of terrible units. Momentum was a kilogram meter per second, and a impulse is just simply a Newton second. So no unique units here. Since both force and time contribute to the impulse, increasing just one of these factors will still produce a strong impulse. So let's consider some ideas here that go around this idea. So we're really thinking about the idea of an impulse being you could either increase the force to get a better impulse, or you could increase the time. In both cases, you would see an increase in the value of the impulse. Doesn't matter if you increase force or you increase time. And these are important factors to consider when you are applying forces to objects. So a bicyclist squeezes her handlebar brakes and applies 20 newtons of force, so that's from her hands, and she holds down the brakes for 30 seconds until she comes to a full stop. So in this case, the impulse is equal to the force, 20 newtons, times the time, 30 seconds. So she gets a total of 600 newton seconds as an impulse. What if she applied her brakes more firmly? So let's say if she, what if she held her brakes down for longer? If she holds the brakes longer, the brakes, not that kind of brake, brakes for 60 seconds, so for a whole minute, then the impulse becomes 20 newtons times 60 seconds, which means that she gets a total of 1200 Newton seconds. Or she could use both handbrakes, right? And for only 30 seconds. And in that case, she would have twice the force because she's using both hands. So she'd have 40 newtons times the 30 seconds. And she would equally increase her impulse to 1200 Newton seconds. So it doesn't matter if you increase the force or you increase the time, both are going to have an effect on the overall impulse. Okay, so let's consider some of these examples that they've given us below. You're sliding down a hill on your toboggan with great speed, but need to stop before hitting a fence. In order to decrease your system, you could dig your heels into the snow, which would apply a force for a moment or two, which would be time, to slow the toboggan down to a safe speed. So in order to decrease your momentum, you can dig your heels into the snow for a moment or two. So here you have you're applying an impulse. You have the force, right? This is the force is coming from your feet or your heels in snow. And you are multiplying that by the time, right? The t, the change in t, which is the t, which is the time heels are up in snow. And that will slow you down. And if you are in a toboggan race, you'll probably be careful with how much time you're putting your heels in the snow. You might just tap the snow a little bit. And this tapping the snow is going to slow will help you maybe get control of the toboggan, but won't completely slow you down. Because as much as you're applying the same force, if you're only applying it over a short period of time, then the impulse is less on the overall toboggan. You're riding your bike to the swimming pool and will be late for your lesson if you don't hurry up. In order to increase your impulse, you need to pedal harder, which is more force, for the next 5 blocks, a longer period of time. So in order to increase the impulse on your bike, you need to pedal harder. You need to increase the amount of force. Or you could pedal at a moderate speed for a longer period of time, and that would also increase it. So we should also consider some of the options here that we have when we're thinking about impulse. All right, we'll have some practice in calculating the impulse in our next little sort of quiz, and we'll talk to you next time with our follow-up on momentum and impulse part 2.